fifth graders, our topic today is talking about equivalent fractions. So if we look at the word equivalent, I know we're in math class right now, but let's switch into reading for just a few seconds. If we look at the word equivalent, do you see any other words that might have worked together to make equivalent? That's right. By the way, Mr. Lencher,
Yes.
do you think it's better to try and be wrong than not try at all?
I totally agree. I give those kids credit who are courageous because this is a safe environment, okay? Say, oh, Mr. Adams, I think equal, that means they're like opposites, right?
Well, good try, Mr. Lencher,
Okay.
but not what we're talking about today. That's all right. Thanks for trying, though.
Because do you know what? If I try and Mr. Adamson corrects me, to me that sticks in my mind. Say, no, ooh, that was when I remember that I got it way off, but Mr. Adamson said, no, this is actually it.
So anybody want to give a prediction, a guess of what word might be inside of equivalent? Equal. Who's Julius? Nice job. I think that was Julius' voice.
No, it's these two.
Oh, sorry.
Let me try.
Equal. So guess what? Equivalent fractions are fractions that are equal. Equivalent fractions are fractions that are equal.
So equal, what does that mean? So like if I have, is that the same as if I have 7 apples compared to 8 apples? They're close, right? Is that somewhat equal, or?
Go back to kindergarten. That simple math sentence. That simple math equation. 1 plus 1 equals 2. What is that saying? An equal sign is saying that whatever's on one side is the same value as what's on the other side. Okay? That's what that equal sign means.
Okay.
Equal is a balance. Both sides have the same value.
Well, I like that word balance, Mr. Adamson. Both have to be balanced.
Okay? You have to have the same value on both sides. And the same is true about fractions. So let's talk about that. Let's pretend, well, we don't have to pretend, we can actually do it.
Yeah.
What if we have the fraction 1/2 and we said we wanted to make a fraction that was equal to 1/2? How many people have ever heard of a man by the name of Martin Luther King Jr.?
Ooh.
Dr. Martin Luther King Jr. Civil rights. If you haven't, tune in because I'm going to give you a 30-second snapshot of what Dr. Martin Luther King was all about. Dr. Martin Luther King Jr. was a black man. He was an African-American man who believed that all people, regardless of the color of their skin, should have equal rights. Because do you know, boys and girls, that there used to be a time in our country when if you had different colored skin, you got treated differently? Like, you couldn't go to such a good school. You couldn't drink out of a certain water fountain. You couldn't go into a certain bathroom because of the color of your skin. You couldn't even go into some restaurants. There would be signs above buildings that would say whites only. Now, as I look around this classroom, it breaks my heart to think that a handful of you wouldn't have been welcome in our society because of the color of your skin. Can you control the color of your skin? No. So Martin Luther King Jr. said, I want to make a difference. I want that to change. And he didn't do it with his fists. He didn't go out and fight with his fists. He went out and fought with his words. He gave speeches. He helped people to get what they wanted. So anyways, Dr. Martin Luther King Jr. was all about getting equal rights for people. So he would say, if that white neighborhood over there gets a new school, this neighborhood that services the African-American children, they should get a new school too. Now some of you are going, Mr. Adamson, what does this have to do with math? Let me tell you. Here's how you work with equivalent fractions. We're going to pretend that top number is the whites, And I do apologize for using the phrase blacks. I don't mean it to be offensive. It's just a term that is sometimes get used. If you prefer, I can use African Americans. Either way. But what we're saying is that if we're going to do something to the top number, we have to do that exact same thing to the bottom number. And we're talking about multiplying usually. Times. So what if I say, all right, the top number, the numerator, let's do times 3. What does Dr. Martin Luther King Jr. tell us that we have to do for that bottom number?
The same thing.
The exact same thing.
Bingo.
The exact same thing. Not, well, kind of. The exact same thing has to happen. Because 1 times 3 is?
3.
And a dry marker. 2 times 3 is? 6. Good. Give yourselves a pat on the back. You just created equivalent fractions. How many people 5 minutes ago said, I can't do equivalent fractions? How many people thought that? I don't know what equivalent fractions are. I don't know how to make equivalent fractions. If you're one of those people that just raise your hand, thank you for being courageous.
Yes.
And admitting, hey, I was a little bit confused. But you just did it. We just made equivalent fractions because we said 1/2 is equal to 3/6. And remember that equal sign is saying balance, the exact same value. So,
And Mr. Adamson too. So 1/2. This is the same thing as saying 3/6. This value, this whole circle, does not change.
here's what's going to
Right?
happen.
See, look at that. Does this piece of pie get any bigger or smaller?
No.
No. And instead, Mr. Adamson would just be filling in. Oh, yeah, or filling in. Yeah, so he would just be filling in those 3. And look at that. Is there still a half that is shaded? So yeah, you can check your work. Say, okay, is half this cookie still shaded? Yup. Is 3 pieces shaded? Yup. So this whole value right here does not change. So remember that. Because sometimes you look at this, I know that when I was learning, I looked 2 smaller than 6. 6 is way bigger. So of course that's not equivalent.
But what happened is we had an equal change. We had the same change happen to the numerator, top number, and the denominator, bottom number. I'm going to share with you a quick story that really hits home with me. My grandpa, my mom's dad, I never got to meet him. He died in an accident in a mine before I was even born, before my parents were even married. But the story that sticks with me the most was whenever my grandpa would order a pizza. He was a hungry man, apparently. So he'd call the pizza place back home in Michigan, and he'd get a whole large pizza. And he'd always say, and they'd say to him, how would you like that cut, Bud? Because that was his nickname, was Bud. And would you like it cut into 8 slices? Or would you like it cut into 16 slices? And he would sometimes jokingly say, I'm kind of hungry tonight. I want 16 slices. Or on some days he'd go, I'm not feeling too hungry tonight. I only need 8. What's kind of the joke of my story with my grandpa and his pizzas, Kendra?
That he uses both of them, like.
Yeah, okay, he uses both of them.
That they're both the same.
Yeah.
They're the exact
Bingo.
same. So it didn't matter if my grandpa ate 8 eighths of that pizza or if he ate 16 sixteenths of that pizza. He still ate one whole pizza. Okay? So think about that.
It's a funny joke when you think about it. Think about it. He was being kind of
silly.
Silly or ironic or
Now, so we talked about how you can multiply. Now, could I have done times 4? Could I have given each of this group 4 pieces of candy? Sure. What would I have to do to that group, though? If I gave the top times 4, what do I have to do to the bottom number to
All
get an
hands should be
equivalent
up. All
fraction?
hands should be up. We know this. Come on, show Mr. Adamson who's boss. Tell him, show him
Remember my rule. Whatever you do to the top, you must do to the bottom. For those of you that aren't raising your hand, let me give you an example of what I mean. By the way, please do not spill the beans. Please do not tell others about what just happened in math class. So, here's my question. So we're going to pretend the front row here is the numerator, the top number. We're going to pretend that the front, whoops, sorry, on the ground. Whoop. We're going to pretend that this front row is the numerator. If you're in the back row, what are you thinking right now?
Yeah, what are you guys feeling?
Come on, you guys, you got to rev up the emotions. I'm telling you right now, you are going to...
You're not getting any.
You're not going to like me too much this year if you say... I'm telling you right now, you have to be an active learner. Okay? You have to. I don't want anyone sucking up oxygen without helping in our classroom this year.
How do you feel right now, Julius? Tell me your true feelings. How do you feel right now? Angry.
It's not fair. It's not equal. What are some other people in the back row
Caitlin,
thinking?
how do you feel?
Jealous.
Kind of uneven because you guys moving.
Okay, let's go back to Riley's point. They got something that we didn't. So how do you think... You want to pass some of those down
Yeah,
there?
pass one of them. Take one and pass one down. Take one, pass one down.
By the way, you are allowed to chew this, but do me a favor. Leave no trace.
Yeah.
Throw your wrapper in the garbage. Spit your gum when you're done with it in the garbage can, please. Mr. Lyncher, you need one?
Sure, thanks.
So, think back.
Keep it, and we don't want everyone, just keep it by your desk right now, guys.
Yep.
Hey, stay seated. We don't, just keep it, put it in your pocket, put it by your desk, and when you leave, then you can discard the paper.
So, let's apply that same gum idea to what we just did on the board. I just gave the numerator, a piece of gum. In this problem, that piece of gum is times 4. That's what we're going to do. We're going to say times 4. What did everyone in the back row say?
It's not fair.
It's not fair. I want it too. I want the same thing. So what do I need to do to this 2 to give it the same thing?
Come on, guys. Come on.
I did times 4 up here. What do I need to do down there? Let me give you some thinking time. Maybe I'm going a little too quick. Maybe I'm getting a little too excited. Whatever you do to the top, you must do to the bottom. So what must I do to this 2? I did something to that 1. What must I do to the 2? If you're bashful, if you're shy, let me share a story with you about why I don't care if you're right or wrong. I really don't. I care that you're trying. So let me give you an example of a time that I made a complete fool of myself 2 years ago. It was in 4th grade math class, and I was talking about angles. We were talking about angles, and we were talking about a 360. And we talked about how a 360 was all the way around. And one of the boys in that class said, "Hey, Mr. Adamson, why don't you show us a 360? And guess what I did? I tried to show them a 360. I got about most of the turn. I stepped in the recycling bin. I flipped over and landed on the ground. And all the kids laughed at me, and I laughed at myself because it was silly. It was foolish. But please do not sit in your desk in our math class at any point and go, so, what did I do to the... Remind me of your name. Brianna. What did I do to the 1?
Times 4.
What should I do to the 2?
Times 4.
Awesome. Great job. What's my new equivalent fraction? Caitlin.
8 and 4/8.
4/8. 1 times 4 is 4. 2 times 4 is 8.
Oh, and that's kind of nice. You just go straight across then, right?
Yep. So this is where, those of you who know Mr. Adamson a little bit, sometimes I get sloppy. Ooh, this is an area where even I have to say, slow down, take my time. I want it to be neat and organized. Because I need to be able to say that 1/2 is equal to 4/8. We also said that 1/2 was also equal to 3/6. Because whatever I do to the top, I must do to the bottom. Whatever I do to the bottom, I must do to the top. Okay? So that's a way that you can do equivalent fractions with multiplication. Okay? And if I take a peek at our learning for today, actually let's go dig into our math workbooks. Sorry.
Math workbooks, guys.
And we're going to be on page 3.
Yep, right there. That's right. What's that? I'll just leave it out right now.
And what is the title on the top of page 3? Yes, ma'am. Yes. Find equivalent fractions by multiplying. What did we just do? Found equivalent fractions by multiplying. Perfect. Right away it says circle the unit fractions. Oh, Mr. Lencher.
Oh, boy.
Mr. Lencher, there's that U word again.
Oh.
How many of how many of you are there? One. So we're talking about fractions that have a numerator, a top number of 1. And it says circle the unit fractions up to 2/3. I'm just grabbing a pencil. By the way, that's what we use in math class. Even my son, who now is in college, who is taking math classes that I didn't even take because he's smarter than I am. Don't tell him that, though. Guess what kind of writing utensil Braden uses in college calculus? A pencil. Because in math, you make mistakes. And what's cool about pencils? You can erase your mistakes. So, who would like to tell me, who would like to come up and show us how to circle the unit fractions up to 1/3? Excuse me, up to 2/3. Thank you. See, I make mistakes. Adonis, come on up.
Attaboy.
Now, be careful.
Way to have courage. Get up there.
I'm going to give you a hint, Adonis. Just remember what unit fractions are. I'd prefer if you didn't write up here, though.
Yeah.
So you can use my book there. Because I'm going to tell you right now, is he going to be smarter than I was? Remember, a unit fraction is one something. 1/3, maybe. So all you need to do is circle. Okay, half the battle. I think you're halfway there.
Halfway there.
What do you need to do to get to 2/3 though? Right now it looks like you've got 1/3. So what do we need to do? What else do we need to circle, Adonis, to get to 2/3 today?
There it is.
Bingo. Exactly right. 1/3 and 1/3 would give us 2/3. Perfect. All right.
And guys,
Now,
that number line looks a lot different. I get that, but look at how Adonis had 2 of these circled. Think about that. It's just like a big square like this, and these are shaded. Doesn't that look similar? Doesn't that look similar? Okay, so it's not totally off of what Adonis just did. It's another way to show it. Okay, timelines or those number lines are going to be huge.
okay, go ahead, stand up, pretend like there are $100 bills hanging from the ceiling, and you want to reach up and grab them, but you get kicked out of the game if you top. I think one per group.
When I used to,
$100 bills hanging on the ceiling. Oh, they're all on the floor now. Oh, they're on your chair, but the only way you can get them is if they stick to your bumper. Perfect. Thank you so much. Each of you, whether you're by yourself or maybe in a team of 2, you received a fraction tile box. Okay? Now, so this first one, we're working with thirds. Who can tell us?
Guys, eyes and ears. You need to know what you're doing with these tiles.
Who can tell us what color the thirds are? What color are the third tiles? Abby, they're black. So why don't you go ahead and take out your 3 black tiles, please.
wait. Here's this. Never mind. It's right here. But it says right there too. But I can open it now. Take them out.
Okay, just get out the 3 black tiles. That's what he said.
And just set them on your desk, and you can put them end to end.
Pick up the 3 black tiles.
You can put them end to end, like so. We'll zoom out a little bit. There we go. And then if I look a little bit below, it's saying they want us to look at 6. So what color are the 6 tiles? Chase. Orange. So go ahead and grab out your orange tiles. And I want you to put them end to end right below the 1/3 tiles that you just worked on.
No, I think
Once you've done what I've done, where I've got my thirds and my 6 kind of stacked on top of each other,
Mr.
let's
Adamson.
talk about some observations that you
I'm
make.
picking some up.
What are some things that you notice? Madison,
they're the same way.
first of all, they're the exact same length.
But how can that be possible? The numbers are different. The numbers are way different. Like 3 and 6 aren't even close to each other. How is that possible?
What do you think, Kendra?
Because there's like if there's a 3, there would be 3 tiles.
Yeah.
6 and 6 tiles.
Yeah.
And 3 plus 3 is 6.
Okay. Well, you were spot on it right when you started talking. I think you're perfect. How many thirds do we have? 1, 2, 3. We have 3 thirds. How many 6 do we have? 1, 2, 3, 4, 5, 6. So 3 thirds and 6 6. If we go back to my grandpa and his silly pizza story, 8/8 was a whole pizza. 16/16 was a whole pizza. 3 thirds is a whole. 6 6 is a whole. So we're talking about the same size. It's just cut into different size pieces, right? Any other observations that you make between thirds and 6? They're the same length. I like that. Anything else you notice? Let me help you maybe.
What's that?
Everyone take a peek. What's another thing that you spy? What else do you notice? Okay, they're the same length still, but let's go a little bit deeper. Caitlin?
They're cut up different, but they're still the same.
Okay, so can we maybe talk about these in a number sentence, like equivalent fractions? Like I said, 1/2 is equal to 4/8. Can we make a math statement with this? We said they're equal. We said they're the same length. What's equal? What did we just show as equal up here, Adonis?
That 2 1/6 is the same as
Okay.
1.
Okay, so let's not put a number on them. So we're going to say that 1/3 is equal to how many 6? 2 6. You just proved it. So what I'm gonna zip it for now because I think we've got a good start. And you can work with these tiles. You can continue to work with. You can work with a partner if you choose. I want you just to do pages 3 and 4 in your workbook. Do not go to page 5 yet. That might be tomorrow, or if we have a little bit of time. So go ahead. Go ahead and get a start on pages 3 and 4.
Okay, no. So now we're going to be doing just like